Hello guys, this is Asik Koirala and today we're gonna learn about TensorFlow. This is the introduction to the TensorFlow and I request you guys to install the TensorFlow in your desktop, in your file, and come up here to understand the TensorFlow. Let's give you the short introduction. At the first video I have told you, like, we will not doing this, like we will not using this model to use it for the production. We will be using TensorFlow and the create production grade machine learning model with TensorFlow. So yeah, it is why this is why we are using. So here what you need to know is, first of all, keras. Okay, so you need to know what does this mean, and high level API for TensorFlow. Like, this is all to know about keras. Okay, and then yeah, keras.model.fit, keras model.predict, and this is now. And also after keras you need to know keras as seq sequential. So, like, why do we use keras sequential is to build a model. Okay, and this is how we build the model. Okay, tf.keras.sequential, and like how where we were building the model is by just fitting it. Yes, we will do this, but not at this minimum, not at this early. Okay, so let's just comment the thing that we do not need right now, and let's get started to our video. And let's just comment these things also. So first of all, we need to import in another thing, import, sorry, import TensorFlow is TF. That is all we need to import. Now, first of all, what we need to do here is we need to develop a model. So let's say model is equals to TF dot keras dot sequential, and then one parenthesis, and then a big bracket. Okay. Now we need to create a layer. So the TensorFlow consists of the methodologies of deep learning. Okay, so you also need to understand what is neural network. So here we will be using neural network. We will use an URL DWRK neural network. Okay, so if you don't know neural network, just leave a comment. I will make a specific video for neural network to understand neural network. And the model that we develop using TensorFlow is basically includes two major ports. One is input port, yes, and another is output port. Okay, so between these things, what we need here is we need neural networks. Any URL, sorry, neural networks. So first of all, we have input port, okay, then output port, then neural networks. Like, there is not a specific amount to include the neural networks. Like, if according to your machine, according to your project, you can implement as it is, yeah, as much as you want. Like, the thing it will do is it will help our machine to become more accurate. Okay, how no, how does the neural network help us? For that, you need to know what is neural network, and I am telling you, if you don't know, just leave a comment. Okay, so let's uh, start the let's start building uh, let's start building model. Okay, so we used to build model like this, right? And yeah, and so basically, what does the models of TensorFlow includes a various layer. Like this is the first layer. Let's say this is the input layer. This is input layer, and these all are neural networks, and this is output layer. So this how the this how we deploy the model using TensorFlow. So this is if you can't understand what we have doing is just leave a comment, and for now just understand it as a syntax. Okay, for deploying model we need to do this. One at the last I will also describe, and then dot I and input. Now it have shape, so we need to give a shape. What does shape means? Shape means the amount of data that we are giving it input. So here we have four shapes like area, bedroom, bathroom, and parking. So these are the four datas that we are giving it. Okay. So this is input port. Okay. Now then let's draw a neural network. Tf dot keras dot layers. Sorry, what did we do? Oh yeah, we need to put here comma. Okay. Then dense. So this is the neural network, and now we need to give here an activation units any, and then activation. So unit, I don't know where to give an unit, but let's give first activation. Okay, like let's say unit is equals to any. Okay. Okay, then we need to give an activation. So activation, now here we are giving relu. So what does this activation do? It's basically a convert a non. It's basically introduce non-linearity in the model as well. Okay, so it just helps us to include the non-linearity in the model. Okay, that is all. It's why it is here. It helps to include the non-linearity. Okay. Now last is our output layer. Keras dot layers dot dense for output. OUTPUT. No, we don't have anything as output. Dense, and I guess here is output. No, here is one. Okay. Now we have created a model like this. One single line is equals to this four lines, but this four line is more effective for the production. Okay. Yeah. Now let's fit the model. Okay. So model dot fit. So let's see what does model dot fit do here. Like we are passing these two variables first. Okay. Let's pass these two variable. Okay. This is mandatory. Now we need to pass an epoch. Epochs. So what is epoch? I will come to it. Let's complete this line first. Okay. Epochs, let's say 100, and we need to give yeah, batch size, right. Batch size is, let's give 36. Okay, and we need to give here equals batch size and verb ver, oh, sorry, ber. So barbells is equals to, let's give one, or let's give two. So let's see what does this thing do. I hope you guys are clear with these things only. Now epo's batch size and verbose are new to you. So previously in this type of model, uh, it circulates for one cycle only. Like it's only analyze the data for a cycle. Like the number of cycle for this model, this fitting is one cycle. So epochs do what is it's epochs basically means the number of cycle for the data for to analyze the data. So what we have given here, we have given 100 cycles. So basically the analyzing will run until 100 cycles. Okay, now let's come to the batch size. So what does the batch size mean is basically the 36. Here we have given 36. So at one cycle it takes the 36 sample. Like these are the sample data, right? So from the sample data we have separated train data also. So from this train data it will take the 36 sample data for one cycle to make it accurate, and the verbose means the output. Let's let's see if we are good up to here or not. uh yeah, unit any is not, oh sorry, I just leave it any, right? Okay, let's see. Oh sorry, yeah, this is not the way I just write it. Let's give it 64. Okay, and we have model. Let's see if we are good up to here or not. Fit data model dot fit. Oh yeah, right, we have missed something here. Model dot compile. So here optimizer and matrices. No, this is not a mandatory. We optimizer. So let's say optimizer OPTIM. Optimizer is equals to ADIM. So let's see what does this thing. So optimizer we need to give uh, optimizer while compiling the models that we are building in TensorFlow. So Adams means it refers to the regression. Okay, like if we are solving the regression problems, then we will give a Adam optimizer, and then we need to give a loss function here. So here loss function is mean square error. So this is our loss function here. Okay. So yeah, we are good up to here. Now what we need is basically predict. So let's predict the data. Prediction. Prediction is equals to uh model dot pre predict, and yes, same thing. What we need to give here, we need to give x test, right? Sorry, not test, test. Print y test and prediction. So let's see if it's work or not. I hope you guys are clear up to here. There's nothing that we did more. Like only that this line is expanded up to this line, right? Okay, then let's just run it. Moment of truth. Oh yeah, it's at the last test. Yes, yes, 1 Prediction level, predicted data. I don't know. Let's clear this and let's run it again. Hmm. PLT dot plot. Plot? Where does the plot come from? Where does this plot come from, guys? Let's just remove this code. Oh, sorry, I haven't commented this. Okay, let's go for it. Okay. First, let's make the terminal big. Okay. So what I said, what does EPOS do is this is one cycle from the 100 cycle, two cycle, three cycle, fourth cycle, and it is gone for the 100 cycle. Okay, so the cycling of data set is done up to 100. So it what does it will do, it will helps to increase accuracy, of course, and let's see if it is accurate or not. No, it is not that much accurate. I don't know why. We are meant to get accurate, but this is epoch, yeah, 13 by 13. So I hope you guys understand what is epoch and what does. Mhm. I hope you guys have understand what does epoch mean, what does batch size mean, what does bulb. Let's give one, okay, and then let's just run it if we get accurate. Let's see, 50,000. This is our prediction, right? Prediction is 50,000 and the actual is 22,000. Oh, wow. There's and 22151. Let's see, 22 good, 10 bad. So like yeah, it is being back and forth to the prediction. Let's plot the graph on it. Okay, so we have the graph and let's just on comment this and let's see what does the graph plot us. Predcti, pre. Sorry guys, I know this spelling is mistake, but better to change in only one place rather than two. Okay, let's see it in graph. What will it get? Oh yeah, so actual versus predicted house price, right? So these are the actual houses, and these are the predicted. So you can see, you can what you can see here is like it is. Oh, this is for area or bedroom. Hmm. This is area, but I have given a bedroom. Okay, let's give a yeah. So this is our predicted line, and these are the actual data. So like what does this illustrate is if you guys still are confused about what does this thing is do is like this is the price and this is the area. Okay, so as the area is increasing, the price is also increasing. Okay, so area is the independent, so price of the house is depending upon the area, right? So that is what the graph is showing. Like if we take the another value, let's give one and let's give you a bedroom, bedroom, and let's just run it, then let's see what we get. Yeah. So bedroom, there are one, two, three, four, like this data, and bedroom the here is the highest bedroom, I guess. Here one, two. So basically, what this also is illustrating is as the bedroom increases, the price have also been in increasing, right? So that is what it is showing. Like you can go with any of the data, like bedroom, we have bathroom as well, we have bathroom. Yeah, so you can see. So the like this is what the analyzing data means. Okay, so you need to view the data and calculate the what are the independent and dependent values. So here these are the data for the bathroom, right? So the bathroom is going on increasing here, right? So yeah, I need to do this. So as the bathroom is increasing, so at the first, yeah, it's okay. Like the pricing also increasing, but between it is not playing any role for increasing the price. But at last also, price is also increasing. So this how you analyze the data by visualizing it. So let's do for parking as well. So let's analyze the data for parking. Let's see what we get. Let's run this. Yeah. So there, here we get the parking, right? And let's zoom to these things. Oh yeah, yeah. So these are the parking, but as the parking is increased, sorry, what did I just do? So actual data means these things. Yeah, right. So the parking is also not making anything for pricing. Okay, like not that much it is contributing. Like here, here the less parking, more parking. The price is linear here, and the here is slightly increasing. You can see like here the it is slightly increasing. Sorry. So here price slightly increasing, slightly decreasing as well. Price as the parking is goes on increasing. So yeah, so this how you read the data using the plot. Okay, so this is only two-dimensional plot. You as a ML engineer, you need to analyze the data in three dimension as well, like in a round shape as well. So yeah, so this is for today, guys. And on upcoming video, like we might look for a quite bigger project for this. Like let's okay, yeah. I just say you like there's no matter if we add this dense layer, right? So yeah, it doesn't matter really because it helps us to make our machine accurate. Okay, let's see what how much accurate. Oh yeah, this is the magic of the TensorFlow, right? As the bathroom, the you can see the price, the prediction. These are actual data. These are prediction. So this how the TensorFlow, the neural networks exactly affect us. Like 25, 84, 59, right? 25, 48, 62. it's kind of close, right? So this what this neural network. So we will talk how does neural network help in making machine more accurate okay, so next video is about the neural networks, right? Ready? So just be ready for next video, and thank you so much, guys.